For example, another thing you can do to increase horsepower, which of course is on the top end of the engine, is machine some of this surface off the head so that ridge would be shorter. That increases the compression ratio. If you've machined a little bit off here, this might drop to, say, 9 or 8 cc's. So you'd get higher compression. That's free horsepower. The only disadvantage of the free horsepower by higher compression is you have to spend more expensive fuel to operate your engine so it doesn't pre-detonate, and it increases nitrous oxide emissions. Another thing you can do is change your ignition module or spark box to give it like an MSD, multiple spark ignition, or even 2 spark plugs per cylinder. Another major step modification you can do to an engine: take it to a machine shop. They remove the valves that are in the heads. They bore out the opening bigger so it matches better to those larger intake and exhaust ports. They press in a new valve seat on each side, and they put bigger valves in. You can only make valves as big as they can be until the 2 seats touch each other. Some people like to get more horsepower out of an engine by putting, of course, a camshaft in that likes to flow better at higher RPMs, but also then you have to put stiffer valve springs in for higher RPMs so that the valves can come back fast enough that the piston doesn't hit them. Higher RPM engines demand lighter pistons, so the whole side might be cut out. The piston would have to be stronger, like a forged piston, of course. You'd have a lighter rod. The lightest, strongest rods are titanium rods. Aluminum rods suck for performance engines. They'll just break right away. If you have a rear drive vehicle, so your engine fan would be here, you can put a clutch fan on it so the clutch slips when you rev the engine so it's not blowing so much air and stealing horsepower. Or you can completely remove the fan that's driven by the belts and pulleys on the engine and put an electric fan on that only comes on when necessary. You can also change your pulley sizes so that they're not driving the power steering and alternator as fast and water pump as fast, then stealing horsepower. You can even take off the water pump altogether in the engine and put an electric external water pump on it so it's not stealing any engine horsepower. Of course, to improve the dynamics of flow, you have to go right to the back of the vehicle. So that means a larger diameter exhaust system or dual exhaust, no muffler or higher flow mufflers, no catalytic converter, or a larger higher flow catalytic converter, or side pipes, side exhaust, all different types of things you can do with exhaust to increase flow. But of course, every time you do that, your engine needs more fuel. When you put a high RPM race cam in your engine, well, then it doesn't want to idle because it's designed to work properly at high RPMs, so it has that really lumpy, snappy, chuggy idle. It also gives you horrible fuel economy at low RPMs and no torque at low RPMs. So to keep the engine idling, you have to have your engines idle at 2,000 or 3,000 RPM, which kind of sucks, but that's life. So then the next thing you have to do if you have an automatic vehicle is put a stall torque converter in it. And that means it's a torque converter that just doesn't seem to want to work below 2,000 or 3,000 RPM. It just slips. Like it's not, the fluid that's in the engine being driven by the engine isn't pushing the other half around until it gets to a higher RPM. Some people just quickly do that by cutting them in half on a lathe, taking some of the vanes out, those little plates, then welding them back together. Now I've talked about most of the things you can do to an engine to soup it up that have to do with an engine that runs on atmospheric pressure. That means normally aspirated, not turbocharged and not supercharged. Air pressure is at 14.7 psi, pounds per square inch. So every time your intake valves open up, it rushes in there just by its own static pressure at that psi. Well, next major modification is turbocharging. By far and away, turbocharging is the way you can modify an engine to give you the most horsepower, because it doesn't steal horsepower from your engine like a supercharger does. A turbocharger has, of course, a smaller exhaust manifold, usually just so it can still fit under the hood. And then it has a turbine in a tightly sealed in a chamber that funnels all the exhaust to propeller blades that spin up to 100,000 RPM. Then a shaft goes over here, and there's another container, almost exactly the same, with another set of turbine blades that sucks air in and compresses it because it's spinning so fast, and then blows it into your engine. Turbochargers can run anywhere from, say, 7 psi to over 50 psi. Of course, your engine has to be built up at the bottom end, have stronger head bolts, stronger head gaskets, higher flow and higher pressure oil, a better crankshaft, better pistons, better connecting rods. It has to have so many modifications if you're going to put a bigger turbo on it, especially if it wasn't made for a turbo whatsoever. Then you'll have to lower your compression ratio. Turbochargers need coolant and oil plumbing hoses hooked to them too. They also have a pressure metering system called a wastegate. When there's the correct amount of maximum pressure in the intake system of your car, some of that pressure is diverted and blows into this spring-loaded diaphragm, and it pushes this little lever over, which opens a little dumping valve and dumps some of the exhaust around the turbine wheels so it misses them, and that slows this thing down a little bit so you don't have too much pressure and blow up your engine. You can't put a supercharger or a turbocharger on any engine, especially a fuel-injected one, that doesn't have a computer system that doesn't understand pressures above 14.7 psi or atmospheric pressures. So they need a map sensor and a type of computer that can read those pressures and give enough fuel for all that extra air. Chargers, although I don't have one to show you, are more simpler for novice mechanics or not extremely professional turbo mechanics to install. You just have to find some room on your engine, or if it's an 8-cylinder engine or a V6 engine, you just take off your intake manifold. Hi, random cattage. Yeah, you want to explain things? You just take off your intake manifold and mount the supercharger in the valley of your engine. Right, kitty? Aw, hi, Teddy. On cars like this that don't have a valley to mount them into, you have to find some other place on the engine to mount it so it can still be driven by the belts of the engine. That's why superchargers can't put out as much infinite horsepower as a turbocharger, because they steal some of the RPMs and torque it takes to run your motor to run themselves. Yeah. So superchargers sometimes too also have to have an oil feed line go to them, but they don't have to have water cooling or coolant flowing through them like turbochargers do. Of course, if you have a supercharger or a turbocharger, it's much more efficient and effective if you put an intercooler on your engine. An intercooler looks like a radiator, it's just usually thicker. You would mount it over here, say for example beside your radiator, or find some other place. Sometimes people mount them over there. They'll take out a fog light to do it. You're getting in my way. Yeah, you need some catnip? An intercooler is like a radiator. All it does is have air pass over it while air is flowing through it, and that cools the air that's been compressed, because every time you compress air it gets hot. And hot air is bad because it causes pre-detonation, and also hot air is expanded so it's less dense, and your engine will work better running on more denser air. You're really stealing the show, aren't you? Yeah. Now, the more compression you have in your engine, which could be by static boost, could be by static compression ratio, or the effective compression ratio because it's boosted or supercharged, you have to increase spark voltage. The more air that's being compressed in your engine, that means the more air that's going between the gap of your spark plugs. Well, air is an insulator, and that prevents the spark from wanting to jump to gap. So it's better to have a higher output ignition coil if you have higher compression or boost in your engines, so with a higher voltage. One thing I forgot to mention about carbureted vehicles is, once you've done head modifications to get more dynamic flow, different camshaft, better exhaust flow and all that stuff, well, of course you're going to have to put a bigger carburetor on it. They're measured in cubic feet per minute, how much air they can suck in at wide open throttle. Oh man, kitty. Alright, get your ass out of my face. So what all this boils down to, if you just own a modern, everyday, fuel-injected vehicle, it's not easy just to bolt on something and increase the horsepower. There's a lot, it's just not like the old days where you could just throw a carburetor on and a set of headers and a different intake manifold. It's serious modifications. You can do little things like air, like a cold air pipe. And different exhaust system and stuff like that, but still, there isn't a lot of things you can do, especially on a vehicle that has to pass emissions tests. Alright, kitty, we can go in for some nip and hugs. How's that? Meow.